Welcome to section 7.4. Oh, we're getting down to the end. We only have 2 more sections after this section. Oh, yay! Well, this is going to continue with factoring, but this factoring is going to talk specifically about special types of trinomials, which are going to be perfect square trinomials. And then we're going to talk about binomials. Well, binomials are going to be in 2 different forms. They are going to be what we call the difference of squares, or what we call even powers. And that's 2, 4, 6, 8. Even powers. But then we're also going to factor cubes. Okay, cubes are to the power of 3. Now, when we do the cubes, there is a pattern. Regretfully, you just got to memorize it. And we'll talk about how you can memorize it or use what I call the building blocks of a cube. Well, let's get started. Okay, we have special trinomials that are in the form ax squared plus bx plus c. Now, these are a 3-term polynomial that create a perfect square. Now, there is a long way and there is a short way to do this. The long way is the way we've still been factoring these as we've done in the past. But there is a shortcut. Both the a term in front of x squared, and sometimes it's a number. It can be 1, it can be 4, it can be 9, it can be 16, and the c term must have 2 identical factors. And the 5 term, okay, and this should say the b term, there's an error there, from the sum of these 2 identical terms must give me here. Now, let me explain it to you because it's a lot easier to do. Okay, then let's look right here. Okay, right here, my a term is 1. And remember, 1 times 1 is 1. Or r times r. This is my first term. This term, and it's got to be both. This is 5 times 5. Okay, if you remember, the a was 1, the c was 25. Remember how we took a times c? Well, we want to get 10. Well, don't these 2 terms add to 10? Yeah. So this is going to give us r plus 5 times r plus 5. This is the shortcut, but it only works if the first term and the last term can be squared. Remember, it says the sum and the difference of perfect. It says special trinomials, perfect squares. Squares is the square root. So this is our answer. And if you FOIL it, we're going to go back to what we get. But also know that this answer can be written r plus 5 squared, because I got two identical ones. Okay, let's try this again. Okay, this is n times n. Okay, we still have a minus, but 36 is 6 times 6. If you remember, this would give me a n minus some number, n minus some number, because remember, we want 36. Well, this will give me 6 and 6. Because if I FOIL this, I'm going to get 12 in the middle. Or my answer is n minus 6. Now, these are special trinomials. If I can't take the square of the first and the square of the last, they both must work. If the 6 and the 6, and my middle term is not 12, I can't do it this way. It's not a special trinomial. If it was 13, we'd get something totally different. Because remember, 36 also is 4 times 9. Negative 9 and negative 4 is a negative 13. So they've got to add to the middle term. Add to middle term. Or the BN term. Let's try again. Okay. Now, this one's a little more different. Okay, do you see I have a 3 here? Or a 9 here? You see I got a 9? If I take the square, this is 3x times 3x. If I take 16, this is 4 times 4. Well, remember, this is my A term. This is my C term. If I multiply A times C like we've done in the past, I'm going to get 144. What's the square root of 24? Or 124? 12 times 12. Look at what I got here. This 3 multiplies by 4 to give me one of the 12s. 3 times 4 gives me one of the 12s. Now, I could do this the long way, but I'm still going to come up with 3x plus 4, 3x plus 4. This is known as the shortcut. But it only works if we can get the middle term. And this one is a little more difficult because we still have to take the A, which is 9, and the C, which is 16, and multiply them together. But this time we take the root, or find two identical factors that make 144, which is 12. And then you take the A and the C that we got through the shortcut by taking the roots. If they give us 12 plus 12, I have my answer. And remember, this can also be written 3x plus 4 squared. Now, if you want to do it the other way, please. This is just now coming to the end of the chapter, and we're going to have a few shortcuts that we can take. If we can take the shortcuts, it helps a lot easier. And I'll let you know that some of these shortcuts are going to be very important if you're planning to take 482. Now, with that said, there is something else. There will be times when these perfect square, notice perfect square trinomials, have a GCF. And if you remember, it's got to be taken out first. And I'm going to show you how it works. Okay, here's our problem. Now, first off, I have an 8, okay? If I take the root, because remember we want the square root, we want the perfect square. Square is a root. Well, 8 is not a perfect square. So therefore, we got to take a look. Is there a number that I can divide by 8, by 56, and 98 to make life a little easier? Well, let's divide each one of these numbers by 2. Well, this means I have a 2, but notice what I get. 4t squared plus 28t plus 49. Okay. Well, now look what happens. If I take the root of 4, that's 2 and 2. And remember, I get a t that goes with each 2. But then I come down to the 49, and this is 7 times 7. Okay. Well, if I take A times C, which is 4 times 49, I'm going to get 196. Well, 196 is going to be 14 times 14. Okay, but notice this 2 times 7 gives me 14. This 2 times 7 gives me 14. Does this add to 28? Look at the middle number. Yeah, it does. This means that that wonderful 2 that I took out still has to stay, but I have 2t plus 7, 2t plus 7, or 2t plus 7 to the power of 2. I can't forget that 2. It's still part of the problem. So when you get a trinomial, if you can find the perfect square of the first term and the last term, then this is considered a special trinomial. And remember, you could still do it as we've done from the beginning of this chapter. You're still going to come up with these answers at the end. It's whether you want to use the shortcut or not. It's just another way to help you factor. Okay. Well, let's take a look at this one. Okay. Well, this one, okay, I agree. This 9 is 3 times 3. This 9 is 3 times 3. But you also have these G's. That means I have a greatest common factor, definitely of G, but 9. It may not seem like that, but it is. So that means 9G is coming out. And what do I have? G squared plus 2G plus 1. And remember, this power has to be a perfect square. That's a cube. That should tell me that I have to take a G out as a greatest common factor for sure. But then the 9, the very first number. Can I divide 18 by 9? Yes. Can I divide 9 by 9? Yes. Now remember, this is a 1. This is a 1. So if I take the root, 1 is going to be 1 times 1. That's over here, 1 times 1, which gives me 9G, G plus 1, G plus 1. Notice how the signs line up. Or 9G, G plus 1 squared. Now this is the shortcut, and I'm going to re-emphasize, you can still do it the long way. Does it matter? No. This just helps you because math is patterns. If you can recognize patterns, you can get to the end a lot quicker. And it's a lot less brain power you're using. But you've got to recognize what you're starting with. Okay. Now, this is the perfect square trinomial, or what we call special trinomials. But we're now going to enter into the world of binomials. Now, I want you to put this in your brain. In the form of x squared minus c. Okay. Or also know this as a x squared minus c. Either one is correct. It's a two-term polynomial, and here's the catch. It's even. Okay. Now, I will let you know that there is a long way and a short way. I'm going to show you the long way initially, but then I'm going to show you the short way. But I do need to remind you that there is one and only one binomial to an even power that will always be prime, or what we call non-factorable. And I want to talk about this binomial first. This is the binomial that has the sum of squares. And you have to look at this term as a trinomial. But you've got to notice what's in the middle. That bx term is got to be 0. And this type of binomial can't be factored. It is going to be prime, and there's another alternative, but most of the time it's prime. And the reason for it is we cannot add two numbers to make the middle term, which is 0x. When you add two numbers, unless they are zeros, five plus five is not going to give me 0. The only is if we can subtract to get 0 in the middle. And let me prove it to you. Now, because the sum of the binomial squared never, and this should say has, two factors that will add to 0, think about this one. What would I put on these blanks to add to 0? Nothing. But look at the bottom one. Do you see I have a minus sign here? Well, if you remember our setup, it's x squared plus whatever number I put here minus this sign, and this sign can subtract to give me 0. It's got to subtract to give me 0. And let's take a look. Remember I told you that there is this problem is going to be prime? Well, that's going to happen. If you have a plus in the middle, there's no way we can get 0x in the middle, even though it's not written. But there is a second possibility. You have a GCF. Now, this is a binomial. It's got a plus in the middle. But look at the number in front of x squared, that a term. Can I divide 2 out? Yes. And if I can, this is my factored answer. I can go no further. No further. So the sum of squares, and it's the sum of binomial squares, you have only two choices. It's prime, or you have a GCF. And you have a GCF because you have a number in front of x squared. Now, this is where the fun comes in. Okay, this is the difference of squares. Now, this is the power of 2. Now, this is an even power. We are going to see a problem that has a power of 4. That's still even. The process is still the same. Now, notice right here, I have this middle term. It is plus 0by. And I've got a minus right here in the middle. This is what you have to think. This is the old way that we've done it. Okay, plus 0by. That's the middle term. Now, when we try to factor it like we've done in the past, we'd put a plus here, minus here. And the reason is we need a negative 16. Negative 16. One of those places has got to have a positive sign. and the other blank has to have a negative sign. Now, if we take 25 and 16 and multiply them together, we're going to get 400. If I take 400 and take the square of 400, I'm going to get the number 20. And then the middle term will have by on both blanks. Now, as we've done in the past, we took out a GCF here of 5b. That left me with 5b plus 4y. And then we had that negative sign. And then we took out a negative 4y. Well, notice these two blanks are the same. But notice what this one is. It's 5b minus 4y. And if you FOIL it, do I get 0 in the middle? Yeah, I do. So FOILing is going to be your biggest help here. If you have a binomial with a minus, you got to get 0 in the middle. Now, this is known as the long way. And I can tell you like long ways. But there is a short way. Okay, here we go. First off, I have a minus sign in the middle. That should immediately tell me that one parentheses is negative, one parentheses is positive. And just like I did before, the square of both terms, and they both got to work. They both must work. If 25 was a 30b squared, doesn't work. Okay. It only works if it can be squared or have identical factors. This will give me 5b, 4y, 4y. Notice they are identical. Well, then we just follow the pattern. We take these two and put it in the first parentheses, and then we take the last two. We normally put the minus first because this is a binomial with a minus. But can you switch them around and put plus and then minus? Yes. But one factor must be negative, one must be positive, and when you FOIL, you got to get 0 in the middle. Okay. Well, let's show you how it works. Okay, first off, I got to have this term. Got to have a negative. This is k times k, 5 times 5. The shortcut is k minus 5, k plus 5. This is my answer. Because remember, this means k squared plus 0k minus 25. When I FOIL this, I better get 0. Notice that nice little 0 in the middle? And it says, okay, I like that. Okay. Let's try it again. Okay, now this one's going to be a little more interesting. I have a minus. Okay, we're going to see if we can take the root first. Because remember, we could still have a greatest common factor. But in this case, we don't. It's 3y, 11z, 11z. 3y minus 11z, 3y plus 11z. And the signs have to be the opposite because we're going for 0 in the middle. We've got to be able to subtract to get 0 in the middle. Now, some of you may think this is an awful problem, but it's not. If I take the root here, it's r times r. Taking it here. Now this is 2/7, 2/7, which gives me r minus 2/7 r plus 2/7. This is my answer. Okay, now right here. See that plus? Now hopefully, without doing too much work, you know this is prime or not factorable. Because this is t squared plus blank, circle blank, plus 100. This blank or circle has got to have a plus. I have to have 0t here. It's not going to work. This is telling me it's prime because I cannot add 2 terms to give me 0 in the middle. It's not going to work. Now, hopefully you see this one. It's plus, but this has a number. Can I divide 8 into both of these? Sure. Which gives me p squared plus 100. Do you remember this is just what we had in the last slide? We had t plus 100. I can't do anything when I've got a plus. This is your second alternative because I have a greatest common factor. That's as far as I can go. I can't go any further than right here. Now, this one you got to be careful for. Okay, first off, descending order. This is 9m squared. Now, right now, it's a plus 36. But I've got to take out a negative 9. This is my GCF. And notice what I get. M squared minus 4. This is m, 2, 2. Because I got a minus here. This will give me a negative 9, m minus 2, m plus 2. This is my answer. Descending order. Gotta have descending order here. And because the first term is negative, I've got to take out a GCF that's negative. Huh? Okay. Now, this is one that we've talked about in the past. Now, right here, this has a 4. Now, you still have the minus sign here, but you have to take it out as h squared, 9, 9. By is 2 identical factors. Now, this is going to give me h squared minus 9, h squared plus 9. The only problem here is right here. Because we started out with a 4, look at this one. We know that we can't do anything with h plus 9. It's got a plus in the middle. But with the minus, this is h, 3, 3. This is going to create 3 binomials. Now, we always put the higher power first, so it's h plus 9. But then this is h plus 3, h minus 3. And I could have put h minus 3 first and h plus 3 in the end. But this gives us 3 binomials because the h squared minus 2 can go further. And that's what I got to do. Okay, now notice this is by 2 terms. This is 2 terms. And it has a minus sign in the middle. Now, the last part of 7-4 is the introduction to what we call cubes, the power of 3. Now, you can have a cube look like this, or a cube looking like this. Both of these factor. They're still a 2-term polynomial, but the power, that's where you have to look. If it's 2, everything we've done so far is done. But now you're going to get with 3s. Now, I'm going to tell you that there's only one way to do this because it sets up a pattern that you have to memorize. Now, I'm going to show you 2 examples. We have the sum of a cube. Well, notice there's my 3. Now, unfortunately, you're going to have to memorize this pattern. And this is the only way cubes can be factored. Now, this time, the binomial, because it has a 3, must have 3 identical factors. Now, if you look at 64, 8 times 8 is 2 factors. Can I make 64 into 3 identical factors? Yes, 4, 4, 4. Now, this is how you start. You must have 3 identical factors. Now, once you've done that, that's the hard part. Because now, here's the second step. We're going to take one x and one 4, one from each column, and we're going to place these 2 terms in a parentheses right here. And because this has a plus between the x cubed and the 4, this is going to get a plus. That's the start. Now, it's what comes next. This is where we create a trinomial. And remember, tri means 3. So a cube is a binomial times a trinomial. And how do we get the trinomial? Well, as you see, this is what we got in the last slide, x plus 4. Well, how do you get the trinomial for the cube? Well, you see those two x's we didn't use? We're going to multiply them. Now, the cube trinomial always changes the sign. It was plus here. The middle term must be negative. It's the opposite sign of the cube and the product of the first two terms, which means x times 4 is 4x. Now, remember we have these last two 4's? Well, they're going to now be a positive 4 times a positive 4. Okay? Which gives me 16. This is the pattern. Now, this is when I have a plus. Well, let's look at the difference. Notice what I have in the middle? I have a minus sign. So technically, I'm taking out negative 4 times negative 4 times negative 4, which gives me negative 64. Okay? But I still have 3 identical factors. Well, let's look right here. I'm going to take 1x and 1 4, and I should say the negative, and I'm going to write it in parentheses, except I'm using the negative that's in front of 64. This is my binomial part. Now, my trinomial part for my cubed, well, again, we're taking x minus 4. But notice what we get. X times x is giving me x squared. The opposite sign, well, if this is minus, this has got to be plus. And it's 4x. That sign changes. And then we have the last two. Negative 4 times negative 4. Notice I still get a positive 16 at the end. This is the pattern of cubes. It's a binomial times a trinomial. That's how we factor a cube. And this trinomial can't go any further. It stays the way it is. You can never factor this trinomial in a perfect square. It doesn't work because you'll never get the middle term in a cube. Now, let's finish up these slides. Okay. Right away, notice I have a cube. Right here, there's my 3. Well, this is z, z, z. Now this is 3, 3, 3. Okay. Right here is the binomial. And this will give us z plus 3. Then we have the trinomial. Well, we start right here. Z squared. Now, this is positive, which means this is going to become negative, and it's 3z. We're taking these two terms and multiplying them together. Now, then we have these two terms, which is plus 9. 3 times 3. Binomial times trinomial. Okay. D, D, D. Now this is 5, 5, 5. Which means that right here, my binomial is D minus 5. 1D, 1, 5. Now what comes next is my trinomial. Well, that's where these two D's come in. D squared. Now the opposite sign is plus 5D. These two terms that I just started with, 5 and D, multiply together. And don't forget, negative and negative is going to give me always a positive. 25. Now, this one can be a little more challenging because first off, I got a cube here, I've got a cube here. Well, that 8 is 2, 2, 2, and each 2 gets an m. So my cube is 2m times 2m times 2m, and then I have 3 n's. This is 5, 5, 5. This is the hardest part of it all, because now the binomial. Okay, this is going to take a 2m and a 5m, and I'm going to write 2m plus 5n. Well, what follows is a trinomial. Well, that's where these 2m times 2m is 4m squared. Now, this term right here was positive, making this a negative, but this is where you got to be careful. 2m times 5n is 10mn. And then my last two terms, positive 25n squared. These two terms that make up this binomial multiply together to give me 10mn. That's my cube. Okay. C, 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 1, 1, 1. My binomial is going to be 1C, 1, 1, which is C minus 1. Now my trinomial, okay, this is where I start using these two C's. This sign must change, and then I'm multiplying C times 1, or 1C, okay, And remember, these two are going to give me a positive 1, because even though I have 3 negative ones, these two, negative 1 times negative 1, is still going to give me the last term is always positive. Now, 64, 125. Now notice this is the cubes, which is 4y, 4y, 4y. 64 has got to have a number, an identical 3 factors, the same as 125 and g. This is the hardest part of it. And then you just have to know the pattern. The binomial is going to be 1, 4y minus 5g. Then I have the trinomial. Well, got to take these two and put them right here. 16y squared. This sign is going to change. Now, this is where I have to take 4y and 5y and multiply them together to give me 20. Now, this has got to be GY alphabet rules. Okay. And then my last two terms are plus 25g squared. That is my answer. Okay, I got 2 more, and then we're done. Okay, y, z, z, z. Y plus z, y squared minus the product of y and z plus z squared. This is the pattern I've got to know. This is my binomial. This is my trinomial. Now, GCF. Okay. Now, I have a 4. Now, there's no way I can find 3 identical factors to make 4. So let me see what happens when I divide by 4. I get 4 here. This gives me k cubed plus, in this case, 27. Oh, this is so nice because this is k, 3, 3, 3. When I divide 4 into 108, I get 27. 27 has 3 identical factors. Okay, so that means out in front, there's my 4. This will be k plus 3. That's this k and this 3. And then, what goes in the trinomial? Right here. K squared minus taking these two terms together and multiplying them, plus 9. This is my answer for the cube. It works every time, all the time. This is the last part of factoring 7 4, because now we're going to need it for the future in how we do other problems. So hopefully you got it. Do take care. Catch you later.